Hi class, this is Dr. Karsten, and today we are doing lesson 18. This is from module 5, grade 4 of EngageNY Math, and today's lesson is going to be all about adding and subtracting more than two fractions at the same time. Now, what I really like about this lesson is that you are going to have some freedom to do things your own way and have some fun with it. So I think this will be enjoyable, and it's really just building on skills that we've been working on, where we have been adding and subtracting fractions already and making mixed numbers or turning them into fractions greater than 1. So for this lesson, you're going to notice that I'm doing something a little different. I'm going to be starting on this practice sheet page. Normally I start with a blank page and then we go into our problem set, but today I'm actually going to strictly be working on the practice sheet, again because we're building on skills that you've been using regularly, and then you are going to be working in the problem set for today. So let's get started. So the way this is set up is that there is a problem and then you have the opportunity on this practice sheet, which you should have in your books, but you don't need it. You can also just follow along or use a piece of paper, that's fine. But it gives you 3 boxes in which you can put up to 3 different answers. So I will not be using all the boxes. I'm going to be focusing on certain techniques that I really want you to work on. I'm also going to be jumping down and going a little out of order with a couple of these, and that's because I think it'll make more sense for how I want to teach this. So let's take a look at problem A. In problem A, what you can see is that we are adding 1/8 plus 3/8 plus 4/8, and they all have the same unit. They all have the same denominator. So these are all eighths. The size is the same, which means when that happens, I know that all my pieces are basically going to be the same size, and I can go ahead and add just the numerators, holding on to those pieces. So I could say, well, let's go ahead and write it over here. So I'm going to write it into this box, the first problem. So I'm going to have 1/8 plus 3/8 plus 4/8. Now, for the first time that I do this, what I'm going to go ahead and do is I'm going to go ahead and combine my 1/8 and my 3/8. So since the denominator is the same, I can say 1 of those pieces plus 3 of those pieces would be 4 of those pieces, or 4/8. Now I can't forget that I have this other 4/8 there, so I have to bring that down and add it to this 4/8, and I'll end up with 8/8. Now I don't know if you've noticed already, but 8/8 is actually just equal to 1 whole. So we could write that too and say, well, that's equal to 1. So let's try this a different way. So I'm again going to write 1/8 plus 3/8 plus 4/8. But now this time, I'm going to, instead of associating the 1/8 and the 3/8, I'm going to go ahead and associate or put together the 3/8 and the 4/8. And when I do that, I get 7/8. But again, I cannot forget about that 1/8. I still have to add that in to complete this entire equation or number sentence. And then I have 1/8 plus 7/8 is 8/8. Now again, I'm not going in deep about adding these because we have been doing adding and subtracting fractions that have the same denominator, the same units, for a few days now, so I feel like you're probably pretty comfortable with it. And that's what I've been seeing when we've been meeting in Google Meets. Okay, and again, 8/8 is equivalent to 1 whole. When my numerator and denominator match, it means that, that it's equal to 1 whole. Again, that means for this particular problem, that since my denominator is 8, it means that 1 whole is cut up into 8 even equal pieces, and I have all 8 of them. So think of if I had a cake that was cut into 8 slices and I had all 8 slices, I would have 1 entire cake. Okay, let's jump into problem B. So when I look down at problem B, again, I have 3 fractions that are being added, so let me go ahead and I'm just going to go and jot this down for us. And I'm going to jump the gun a little, and I'm going to write it twice, just so that I can then just keep working. So we have 1/6 plus 4/6 plus 2/6. So I'm going to start over here. So what I would really, really love to do is to see, is there a way for me to make 6/6? And I'm going to go ahead and do that. Now, can you think about why I'm thinking in terms of 6/6? Well, if you don't, then let's just first go ahead and add 6/6 plus 1/6, then I get 7/6. And what I'm seeing is that I have a fraction greater than 1. I have 7/6. And that's what's making me think, well, if I combine my 4 and my 2, if I can somehow find a way of making 6/6, which I did, couldn't I just say that 6/6 is also equal to 1 and save myself the trouble of trying to convert a fraction greater than 1 into a mixed number? And I can. So by combining, and I know we did this before, but I'm just kind of doing it in a different step, a different order here. By combining the 4/6 and the 2/6 together right away, now if I take it and I say 1/6 plus 1, instead of doing 6/6, I can say 1/6 plus 1 whole. And then I know that I have 1 and a 6. And I guess maybe another way I could have written it was to say I could take this 1 and then add that 1/6. It's 1 and a 6, and that's a little clearer of a way to do it. Okay, so like I said, I'm going to skip this box because I really want to go over and take a look at problem C, and then E, and then we're going to come back to that box. So in problem E, we are adding 5/8 plus 4/8 plus 1/8. So let me go ahead and I'm going to jot those down over here. So I have 5/8 plus 4/8 plus 1/8. And what I want to do with this is I'm going to just go ahead and add them straight across and see what I get. So I have 5 plus 4, oops, sorry about that, 5 plus 4 plus 1. And 5 plus 4 plus 1 is 10. So I have 10/8. And again, I have a fraction greater than 1. And so what I'm going to want to do is pull that apart into a mixed number. Now, since 8 is in my denominator, I know that 8/8 is going to equal 1. And since I have 10/8 here, I put 8 of them there, so I had 10 of them. I put 8 here, that leaves me 2 over here. Now remember that 8/8 is just equal to 1, and then I still have my 2/8, so I have 1, this is 1 whole, and 2/8, and we've done a lot of this, so this should not be new to you. You should be pretty familiar with it. But couldn't I have maybe made my life a little bit easier? Could there possibly be another way that I could have done this where I would have had an easier time with it? And I'm trying to think, well, I really would love to somehow have 8/8 so that I don't have to go backwards. Remember what we did over here, where when we made 6/6, we knew that it was equal to 1 whole. And then we could just add that 1/6 to it. So we'd have 1 whole plus a 1/6, or 1 and 1/6. Well, is there a way we could do that? I don't see an easy way. Like 5 and 4 is 9, so that doesn't make 8s. And 4 and 1 is 5, that doesn't make 8/8. But could I possibly split apart one of these and then add them back together in a different way? So for example, I know that 5/8 plus 3/8 is 8/8. So could I maybe, instead of having 4/8, make that 3/8 and 1/8? Yeah, because 3/8 plus 1/8 is 4/8. Now what I can do is I can go ahead and I can take that 5/8, right, and add it to the 3/8. So I can combine, let me take this and kind of make it really clear. I can combine these two together to get my 8/8. If this is getting really confusing to you, remember, you don't have to do it this way. You can do it however you want. But what I'm trying to do is I'm trying to make 8/8. So again, what we're doing here is I can take that 5 and 3, and I know 5 and 3 is 8/8. So I'm combining those two now to get 8/8, which, don't forget, is just 1 whole. So now what do I have left that I can put together? And I'm just trying to show you guys how I'm thinking about it. Well, then I still have 1/8 and 1/8. So what we did was we took this 4/8 and we split it up into more useful fractions. So I have 5/8 and 3/8 is 8/8, which I know is just 1 whole. And then I have 1/8 and 1/8, which is 2/8. So I'm adding 1 plus 2/8 to get 1 and 2/8. I wonder, is there like maybe another way that we could possibly do this one? Yeah, I'm thinking of another way. So let's do it like this. I'm going to have my 5/8, and I have my 4/8, and I have my 1/8. And again, you can do this in so many different ways. But I definitely see that 4 plus 4 is 8. So what I want to do is I want to decompose this 5/8 into 1/8 and 4/8. And now what I can do is I can take these two 4/8 to make 8/8. So now what I'm going to do is I'm just going to bring all these things down. So I'm going to bring my 1/8 down. Plus I have 4/8 and 4/8, which is 8/8. And then I have this other 1/8. Well, this I can just say is 1 whole. So it's going to be 1 whole plus 2/8. So I get 1 and 2/8. So you can see that I did it 3 different ways to get 1 and 2/8. A nice trick is to try and see, are there ways that we can make, whatever the denominator is, that we can make 1 whole using that? So that's why I'm kind of jumping around a little bit. So now I can bring this one back and I can think, are there any other ways that we could have done this problem? And there definitely are. I'm not going to actually, I think, go into it right now, but we definitely could kind of split things up in a whole bunch of different ways. So maybe take this 1 and take those 4 and take one of those 6 and make a whole, and we'd have 1 left over. You can do it however you see it, or you know what, let's go ahead. Let's have some fun. I'm going to move out around the order that I have these in. So I have 1/6, and now I'm going to write this. Now remember, we can do the commutative property when we have addition. So I'm going to take my 1/6 and my 2/6 and put them next to each other, and then put them next to 4/6. And when I do that, now what I see is that I have 3/6 right here. So I'm going to put those together. Well, I know that 3/6 is just half of 6. So couldn't I take 3/6 out of this one and say I have 3/6 and 1/6? Because 3 plus 1 is 4. And now I can go ahead and I can combine these two. So I would have 3/6 plus 3/6, which is 6/6, which is also equal to 1. And then I just have 1 plus this 1/6 that's left. So I have 1 and a 6. Again, there are so many different ways that you can do this, especially with the addition, because you can really move things around. You're a little bit more limited with the subtraction, but definitely with the addition, you have a lot of freedom to move things around using the commutative and the associative property. You can decompose things to try and make those 6. So here we had a natural 6/6. We had a natural 1 whole because 4 plus 2 is 6. Over here, though, we were able to split things up a little, just like we did in the other one. So let's take a look at some subtraction problems. So if I take a look over here, here it says that we have 11/10 is what we're starting out with. We are going to subtract 4/10. I'll move this up a little more so we don't have all that other stuff in there. 4/10, and then we're going to subtract another 1/10. So let's rewrite it, and then let's see if we can come up with a fun way to do this. What we could do to make this work. So I know the thing that I see first is that I really want to just combine these two. Since I'm subtracting both of them from 11/10, I am actually allowed to combine them. So I'm going to do that and say that really what I could do is say it's 11/10 minus, and let me combine 4 and 1, and I have 5/10. So 11/10 minus 5/10 is going to give me 6/10. And that's because 11 of those sized pieces minus 5 of those sized pieces gives me 6 of those sized pieces. Okay, so let's see if we can come up with another way to do this. So how about I just do it in steps? Let me take that 11/10 and let me subtract 4/10 from it. So 11 of those sized pieces minus 4 of those sized pieces gives me 7. And now I can do that second step where I can say 7/10 minus 1/10 gives me 6/10. So you can see we're getting to the same answer, we're just doing it a slightly different way. And I'm kind of wondering if anyone can realize that we can actually compose this number. It's not today's lesson, so I'm not going to mess you up with it, but you could actually turn that into 3/5. But again, not going to make that today's lesson. So let's do maybe one more way. So what I did here was, remember, I took 11/10 and I did it step by step. First I took off the 4/10 and then I took away the 1/10. This time instead, let's take the 1/10 away. Now remember, this is subtraction. I do have to start with 11/10 in all three examples. I cannot change the order of how I'm doing that. In addition, I could have flipped things around, no problem, but not in subtraction. Oops, I just moved the page. There we go. So let's say that we start with the 11/10, and I'm going to go ahead and subtract that 1/10. So that gives me 10/10. Ooh, that's one whole. But writing one whole is not going to help me with this one, because I want to subtract more tenths out of that. So I want to leave that as 10/10. So I have 10/10. So we already took away that 1/10. So now let's subtract 4/10. And I know that 10 minus 4 is 6. So I have 6 of those size pieces, and the size is tenths. So here you have three different ways that we could have done it. Here we combined the two things we were subtracting, and then subtract them from the original number. Here we did it step by step, where first we subtracted the 4/10, then we subtracted the 1/10. Here we switched the order. So first we subtracted the 1/10, and then we subtracted the 4/10. Now again, I want to emphasize, in subtraction we always had to start with the same number. We couldn't switch things around. All right, let's go to the next page and take a look at a couple more examples that we have here. So we slide this down. We already did the middle one. Let's take a quick look at problem D. So now for this one, we are starting with one whole, but then I'm subtracting fractions. So we don't have similar units there. We don't have common units. Oops, sorry. With one whole, what I want to do is I want to turn that into whatever units I'm using for everything else. I want to have common units or common denominators. So here, since we have 12s, let's turn that 1 into 12s. And what I know is that 1 is equal to 12 12s. So I'm going to first just write what it says here. I'm going to write 1 minus 3 12s minus 5 12s. Now, let me convert that 1 into 12 12s. And then I want to do this similarly how I did it on the previous example. Let me just slide this down so we don't have all that stuff. Where I'm going to go ahead and combine these two. So I'm going to say that it's going to be 12 12s minus 8 12s, because 3 and 5 is 8. So you're not going to go 3 minus 5. These are both being subtracted from 1. So that's why we have 8 12s. So 12 12s minus 8 12s, and I get 4 12s. So now let's think about how we did it in the previous one, and can we do step by step again? Now I already know that 1 is 12 12s. We did that. So I'm just going to go ahead and write 12 12s right from the get-go. And now I'm going to do this first. I'm going to subtract 3 12s from it. So I'm going to go step by step. So 1 minus 3 12s, or 12 12s minus 3 12s. And when I do that, I get 9 12s. And then I'm going to take what I have here, and I'm going to do the second step, which is subtract that 5 12s from the 9 12s. And when I do that, I get 4 12s. Okay, so we got the same answer twice, and that's great. So now let's go ahead and see, wasn't there another thing that we did? You know what, actually, yeah, we could do. Let's do the steps and let's switch them up. So again, I'm going to start with 12 12s. Sorry, I had a little indecision there. But let's go ahead and do it. So now this time, instead of subtracting the 3 12s first, let's subtract the 5 12s first. So 12 12s minus 5 12s, or 12 minus 5 over here, is going to give me 7 12s. And now I'm going to take that 7 12s, and I'm going to subtract that other piece, which was 3 12s. And when I do that, I again get 4 12s. All right, so we show that a couple of different ways. We have one more type of problem that I'm going to show you, and that is if we start with a mixed number and we're subtracting. So if we start with a mixed number and we are subtracting, what we want to do is, first we want to convert that mixed number into a fraction greater than 1. So let's say that I have 1 1/5, and this is one way to do it, and I'm subtracting 2/5, and I'm subtracting 3/5. Let me convert this. Now remember, what I can do is I can say that that 1 is the same thing, and we're dealing with fifths, as 5/5, but then I still have that 1/5. So really what I have here is 6/5. I have 5/5 and that 1/5, so that's 6/5. And now I want to subtract those. Now, let me go ahead and do what I've been doing, what we did in the other problem, which was I'm going to go ahead and combine those and say that I have 2/5 and 3/5, which is 5/5. So I'm going to have 6/5 minus 5/5. And when I do that, I end up with just 1/5. So I don't know if you noticed something here, but we have 5/5 here. So that gives me another idea of a way to do this. So if I'm starting with 1 1/5, and I'm subtracting 2/5 minus 3/5, let me go ahead and let me decompose this. This could also be 1 1/5, and then I'm subtracting, and look at this, this is 2/5 and 3/5, which is 5/5. Isn't that just one whole? So couldn't I say that I have 1 minus 1? Wouldn't that just then leave me with 1/5 if I did that? Isn't that a cool way of doing it? It's kind of like saying that this one and this one cancel each other out. So we could say that we have 1 minus 5/5 is equal to 0, and then I have 0 plus that 1/5, which is just plain old 1/5. So again, these are all different ways that we can do it. I'm not going to do another one because I don't want to confuse you guys more. I think that the way that we did it in the previous problems may have made a little bit more sense for you, but I did want to show you that you can kind of play around with this. So this is more like the first problem, subtraction problems, where we went ahead and we just converted this into a fraction greater than 1, and then we subtracted the fractions out from it. We could have also done it step by step and said, oh, 6/5 minus 2/5 is 4/5 minus 3/5 is 1/5. We could have done that. But we also could have played around with it and done this. You don't have to do this. You can do this however you see it. And I really want to emphasize that. And that's actually why I'm going to do this one just one more way. So we already know from here that 1 1/5 is 6/5. So I'm going to start with 6/5. So remember, 1 1/5. We know that this was 5/5 plus 1/5 is 6/5. And now I'm going to do this step-by-step way. I'm going to say 6/5 minus 2/5 is 4/5. And I'm going to say 4/5 minus 3/5 is 1/5. So I just did it step 1, step 2. So that's really to emphasize to you that you can do this in lots of different ways. So you've seen me do a bunch of problems, and I mean a bunch of problems. So what you are going to work on, I'm going to kind of zoom out for us a little bit here. Sorry, just takes a little bit of effort. So what we did here is I did a whole bunch of different ways of doing these problems. And we did a whole bunch. We did different ways of grouping. You can go back and look at this some more. But really trust yourselves. At this point, you guys are really good at doing these problems. So what your work is going to be that you are going to do independently, and this is why I zoomed out, I wanted to really quickly show you this, is you are going to work in the Lesson 18 problem set, and you are just going to do this page. So it's all these problems, but they are really quick. You only have to do it one way. You can do it whichever way you want. And what's really nice is that other than the fact that you are going to have to convert some of these ones into fractions, so 1 in this case, remember, would be just 12/12 because you're dealing with 12, so you'd have 12/12 minus this. Then you can go step by step or combine these however you want. Here, since we have thirds, we would have 1 would become 3/3 plus the 2/3, so we would have 5/3. So that's just like a little hint of where you're going. But otherwise, you can do these however you want, step by step, combining different things together. Now, I do want to point one more thing out to you, though, on this problem set, and that is that it says, express sums and differences as a mixed number when possible. So if you get a fraction greater than 1, my expectation is that you are going to convert that fraction greater than 1 to a mixed number. And that's what we did before. So maybe you're going to make some smart groupings and associations to help you with that. And that's really more for the addition problems. You can use number bonds when it helps you. And then here, A, they kind of did for you. So you just have to finish it out. It's really nice and easy. So again, you are going to work through just this problem. You're going to do problem 1, and you're going to do A through I, and that's it. But again, they're super quick. So good job, guys. You're doing a great job. I'm really proud of you. I've been really proud of how the teamwork has been showing up, especially in our Google Meets. You guys have been helping each other solve problems. So that's it for tonight. So I hope that you guys have a great day, and I will see you tomorrow morning bright and early in our Google Classroom. Have a great day.